We shall study about the elimination reactions of alkyl halides. So, if we can represent it in general, one alkyl halide, X is representing the halogen, and here there is one hydrogen. In the presence of base like KOH and alcohol, it gives alkene plus potassium halide plus H2. Now here this halogen is called the leaving group, and the other leaving atom is the hydrogen, which goes as H plus as proton, and the molecule is left with unsaturated product, formation of unsaturated product like this alkene. The mechanism of this elimination reaction can be of three types: E1, E1CB, or E2 mechanism. So, first of all, we will study about the E1 mechanism, which is the full form of which is elimination unimolecular. There are two steps in this reaction mechanism. One, in the first step, alkyl halide forms the carbonium ion. Ion. And how it happens, let us see. We see with CH3, we take example of one alkyl halide, in which this is the carbon which is connected directly to halogen is called the alpha carbon, and this carbon is beta carbon, and this is also beta, this is also beta, and this bromine is said to be the leaving group. Now this bromine, it abstracts one electron from this bond and gets the minus charge, and it leaves the substrate forming Br minus, and the other product is carbocation. This is the carbocation intermediate. In step 2, it happens that this carbonium ion which was formed in the first step This is the alpha carbon. This is the beta. Now the base is coming here with a pair of electrons, and these electrons are given to the hydrogens connected to the this beta carbon, and the removal of hydrogen as proton takes place. This base is coming from ETOH, that is ethanol, and the product is simple alkene. BH. Now base is abstracting one proton from here. It is forming BH, and the carbon, the electron that was left by the hydrogen, is forming the pi bond between the carbon and carbon. So there is formation of alkene. First step is the slow step, and it is rate determining. So the first step involves only one molecule of the substrate, so it is unimolecular mechanism. Now we will see what happens in case of the E1CB mechanism. E1CB, its full form is elimination unimolecular conjugate base. Conjugate base. And here we can see that there is the difference from the E1 mechanism. Suppose take one example of one alkyl halide. This alpha carbon and this is beta carbon. Then the base is coming in the first step only, and it is abstracting the proton, and it is supplying its electron to the hydrogen, and hydrogen leaves its electron to the carbon, and this is the first step of the reaction, forming carbanion. Means the electrons left by the hydrogen here are present on the carbon, so carbon gets negatively charged, and this is called the conjugate base of the substrate. Why conjugate base? Because as we know that in case of any acid, if we can represent acid as HB and it gives one proton and B minus, then we say that B minus, this is the conjugate base of this acid. Similarly here, negatively charged species is formed from the substrate which is having one hydrogen also. So this is called the conjugate base of the substrate. And this is the substrate. So this is the fast step. So it will not determine the rate of the reaction. The rate of reaction depends on the second step, which is the slow step. And in this step, carbanion, from the carbanion, there is bromine also leaving. This electron is given to the CC. Here, carbon-carbon between forming the pi bond between the two carbon atoms, and this bromine abstracts the electron from the CBr bond and goes out as Br minus. Here there is the formation of alkene. So we can see that the alkene is formed ultimately, but this is the slow step involving only one molecule. So it is unimolecular with taking place with the formation of conjugate base, and it is elimination of leaving group bromine and one hydrogen. First of all, hydrogen leaves the substrate, and then carbanion is formed. In the second step, carbanion. From the carbanion, there is removal of bromine as Br minus, and ultimately alkene is formed. So we can see here that E1 mechanism, the first step of the E1 mechanism is similar to that of the SN1 mechanism, because there also carbonium ion was formed in the first step. And the second step is different, as in that case, in substitution reactions, the carbonium ion uh, accepts one nucleophile forming substituted product. But here there is again removal of hydrogen also in the second step in the in the E1 mechanism. And then there is formation of alkene. So it is elimination. And in that case, it was substitution. Here it is E1 CB mechanism. And then you will see how the E2 mechanism proceeds. E2, as its name implies, it is elimination bimolecular. It is also called 1,2 elimination because the removal of halogen and hydrogen takes place from the neighboring carbon atom, which are numbered as 1 and 2. This is the 1 and this is the 2 carbon. This is 1,2 elimination. And plus KOH in presence of alcohol gives C double bond C plus KX plus H2. Now taking the example of a simple alkyl halide, we can see that KOH in presence of alcohol C2H5OH, it is forming alkene CH3 CH double bond CH2 plus KBr plus H2. Now how this mechanism is there is a single step process, and in that process we can take this alkyl halide. Now this is alpha carbon which is connected to halogen, and this is beta carbon which is connected to hydrogen, and there is electrons are abstracted by the halogen which is the leaving group, and then hydrogen is coming in contact with the base which is supplying its electrons to the hydrogen, and from this bond electrons are given to the carbon carbon. Single bond is converted to the carbon carbon double bond. So ultimately The removal of both hydrogen and halogen takes place at the same time, and formation of alkene is there. Base combines with hydrogen and there is removal of halogen as X minus. So this is a single step process involving only one step, and both the substrate and the base are present as reactant, so it is bimolecular mechanism. Now, if we take example of an alkene in which there are two beta carbons, then what is the nature of the product? Let us see how the nature of product and what is the yield. This is the alpha carbon, this is beta carbon, this is also beta carbon. So there are two beta carbons present here, and when we are reacting it with KOH alcoholic, there are two types of products formed. One is the major product, another is the minor product. So CH3, if this hydrogen is removed, the product form is this one, CH3, CH2, CH double bond CH2, which is one butene. Its yield is 19% only, and the other product that is formed is when the removal of this hydrogen takes place from this carbon. This is also beta carbon. Then the product is CH3, CH, double bond CH, CH3. This is yield is 81%, and this is 2-butene. 2-butene. This is the major product, and this is according to the Sedzev's rule, which states that the alkyl groups stabilize the alkene. Alkyl groups stabilize the alkene. The alkene, and that is why the alkene that is formed is the more substituted. Hence, more substituted alkene is formed. We can see here that if you see this product here, this is carbon number 1 and carbon number 2. There is there are two hydrogens attached to carbon number 1, and one hydrogen and one alkyl group attached to carbon number 2. While in case of this molecule, we can see that to carbon number 1 there is one alkyl group, and to carbon number 2 also there is again one alkyl group. So there are more number of alkyl groups present on the CC bonded carbons here, whereas there is lesser number of alkyl groups attached to the carbon-carbon double bond, carbon-carbon atoms having the double bond. So the more substituted alkene is the product formed according to the Sedzev's rule. And this mechanism is Bimolecular because there is a single step taking place here, and in this step both the base and the substrate are involved. So it is the bimolecular mechanism. So now it will be clear what is the difference between the E1 E2 and E1 CB mechanisms. Thank you.